All right, so what I'd like to talk about for a few minutes here is the idea of scientific notation in science. Scientific notation is something that came from a very practical place. When you look at science and you're looking at some of the things that chemistry is looking at, you're looking at very small atoms, pieces of atoms, properties of atoms. We start talking about things that can be really, really small. Elsewhere in science, we'll find things that are very large. And really what this is scientific notation is a way for us to work with very large or small numbers in an easier fashion. If you look at the two numbers I have here, I have 12,500. This would be considered a pretty big number, a pretty large number. And I have number 2 down here, 0.0000451. Most people would agree that that's a pretty small number. So these large and small numbers, it would be kind of cumbersome if we were always referring to them with all of these extra zeros that you see, these 2 zeros at the end of the large number and all these 4 zeros at the beginning of the smaller number. So scientific notation really lets us abbreviate how we write a number so that we don't have to keep writing those zeros down every single time. It's very, very helpful when you have these big or small numbers. So anytime you're looking at scientific notation, and turning a number written out in these long forms into a scientific notation style number, you do basically the same thing. You would look at your decimal point in 12,500. A lot of people would overlook this, but the decimal point really exists right at the end there, right? There's just nothing after the ones place. So either way, you take that decimal point and you always move it over the necessary number of digits until it's in its new location right after the first non-zero digit. So I would have moved the decimal point over between the 1 and the 2 here and gotten 1.25, right? Now the whole idea here is that I'm going to write these zeros. I'm going to write the number without showing all of these zeros. That's why I didn't put the zeros on the end. Now I can't just move the decimal point without accounting for that somehow. I can't just make the number 12,500 into 1.25 without doing something to make it work. So what you do is to show the magnitude of the number, to show how many times the decimal point has been moved. You would write in times 10, and then you put an exponent up here on the 10, and the exponent that you put is the number of times that you move the decimal point. So I've moved my decimal point 1, 2, 3, 4 times to get it from its original position to its new position after the first non-zero. So 12,500 would be the same thing as 1.25 times 10 to the 4. That is for a very large, or for a large number, writing it without so many zeros. On the other side of that, right, kind of a same idea but with a very small number, we're looking to do the same thing. We've got our decimal point, and we're going to move that all the way across so it's following the first non-zero digit. So we're going to move it 1, 2, 3, 4, 5 spots. So our new number is 4.51. And like we said before, we can't just move the decimal point without accounting for it, without showing that we moved it somehow. So we're going to do that with times 10. And we're going to, again, put an exponent up here that represents how many spaces we moved it. So we moved it 1, 2, 3, 4, 5 spots again. 5 spots, moved it 4 spots the first time. And we'll show that. Now, you should be noticing something that's a little bit strange here. How come, right, up at the top here, we moved it 4 spots. We showed that just as a 4, and this was a really big number. And down at the bottom, we moved it 5 spots, and this was a really small number. These numbers are basically the same. 4 and 5 for those exponents is not really that different. When you have very small numbers, it's not that you're just moving it 5 spots, but you're moving it 5 spots to represent very small numbers, and you want a negative sign in there. So anytime you're moving the decimal point, you're putting a small number into scientific notation, right? Basically, anytime you're moving that decimal point to the right, you are putting a times 10 to the negative exponent, like -5. Anytime you have a very big number, like in our first example, or times when you're moving the decimal point to the left, you would have a times 10 to a positive exponent, like +4. Right? So one thing that you can really think about to try to keep this straight in your head is that small numbers get negative exponents, big numbers get positive exponents. The last small point here that we should make is that just because we have a negative exponent here does not mean that this is a negative number. Both of these numbers that we're working with are positive numbers. If they were negative numbers, you'd see a negative sign out in front of the number. The +4 on the large number, our first example here, the -5 on our second example here, is just a representation of how big or small the number is, but they're both positive numbers. That's just a quick video on scientific notation and its different parts. Hope it was helpful for you.